An object is launched vertically from a height of 5 feet with a velocity of 16 feet per second. Assuming that g, the gravity due to Earth's mass, is negative 32 feet per second squared, find a formula for s of t, which is the position function or the height of the object at time t, and find the maximum height reached by the object. So in rectilinear motion, we have three aspects: position, velocity, and acceleration. And to go down the list, we do a derivative, and therefore to go up the list, we do an antiderivative or an integral. We want to find a position function, and we're given the gravity. So if we integrate the gravity, we'll get the velocity. So if the velocity will equal the integral of the gravity, the acceleration, which is the integral of negative 32t dt, and the antiderivative of negative 32 with respect to the variable t is negative 32t plus a constant. And that constant is the initial velocity, because v of 0 is equal to negative 32 times 0 plus c, which is c. And we were told that the object was launched with a velocity of 16 feet per second. So that's our initial velocity, and that means that c is 16. So that our velocity function is negative 32t plus 16, or 16 minus 32t. Then our position function would be, to go from velocity to position, we should integrate. So we do the integral of our velocity function, and that's the integral of 16 minus 32t dt. The antiderivative of 16 is 16t, and the antiderivative of negative 32t is negative 16t squared. And then we have plus c, and this constant is the initial position, because s of 0 is equal to 16 times 0 minus 16 times 0 squared plus c, and that's just c. And the initial height, the initial position, 5 feet. So this was 5 feet, so c is 5. And that means that our position function is 5 plus 16t minus 16t squared. And the general formula is s of t equals s0 plus v0t minus 1/2 gt squared. S0 is the initial height, v0 is the initial velocity, and g, well, here I'm using g as negative, so if I'm saying g is negative, I'll go plus right here. So plus 1/2 gt squared, where g is the gravity. In our case on Earth, it's negative 32. So this number became a negative 16. So there's the general formula for vertical projectile motion, the height of the object at time t. Okay, so we found the formula for s of t. There it is. Now we want the maximum height reached by the object. The maximum height occurs when the velocity is 0. So for part B, we will solve the equation velocity equals 0. So 16 minus 32t is equal to 0. T is half a second. And then the maximum height is s of half a second, which is 5 plus 16 times a half minus 16 times a half squared. Half times 16 is 8. Half squared is a quarter, and 16 times a quarter is 4. So that was minus 4, not plus. That's clearly a minus. And we get 5 plus 8 is 13, minus 4 is 9 feet. So the maximum height was 9 feet. It was a gentle toss from a height of 5 feet that went up to a maximum height of 9 feet.